right. Good morning, everybody.
Hello.
Okay, yeah, good morning, everybody. Welcome to today's class in computer and statistics. Um, so in today's class, we'll be looking at introduction to computer. Okay, so I'm trying to start up my screen now. So introduction to computer. Let's first of all define what a computer is. Just as we have there. A computer is an electronic device operating under the control of instructions stored in its own memory that can accept data, process the data according to specified rules, then produce information and store the information for future use. So what I'm trying to say is that any electronic device that has the capability to accept data, process the data, and then produce the information to the user is actually a computer. Okay, not only can a computer um, accept this data, process it, and then give an information as an output. Computers also have the ability to store this information within them for future use. Okay, so that's what a computer is. Any device that can accept, process, and then give out an information. That's a computer. So basically the functionalities of a computer, just like I've said, it takes in data. Now these are raw data, raw file that the user is just a raw file that the user may not really be able to interpret. Then as soon as it sends this data into the computer receives the data, stores the data or the instruction in its memory, and then anytime the data is required by the user, it can now be processed. So as soon as the user is ready for data to be processed, it also tells the computer what to do. It informs the computer that I'm ready for my data to be processed, and then the computer converts that data, that raw data, into a useful information that the user can actually understand. Then as soon as this conversion is over, the information is generated as an output, which falls back to the user. And at this time, the user can now be able to understand, what the data is all about from the information that's been processed by the computer. So basically, those are the 4 steps or the 4 functionalities of a computer. It takes in data, stores this data, processes the data, and then generates the output. I hope everybody is taking note of what I'm saying. All right, so let's proceed. Component of a computer. The computer has 2 components. We have the hardware and the software. So I'm going to be explaining these 2 components for us. Now, the hardware is actually the physical element or component of the computer. Okay, that part of the computer that you can touch, that you can feel, that is the hardware. That's what we refer to it as the physical parts or component of a computer. So that's for the hardware. Examples of hardware. These are hardwares like the monitor, the speaker, the keyboard, the mouse, the CPU, the DVD-ROM drive, So you can see from what you're seeing on your screen, what is being displayed. You can actually touch and feel all this. So that is the computer hardware. All right. So any part of the computer that can be seen, that can be touched, that can be felt is the computer hardware. All right. Then we have the input devices. Just as we have the input device is any piece of computer hardware, okay, that is used to send information, okay, into the computer for processing. So any device, any hardware, okay, that is used to send information to the computer for processing is actually referred to as a the input device. So what the input device does is that it translates this data that I said that we can understand, that the humans can understand, though that data has not been actually processed. It sends it to into the system for processing. The common input devices that we have is the keyboard and of course the mouse. I have some examples, other examples of input devices. So these are the computer hardwares that is used to send information. So without this, the computer will not be able to receive these informations. The data that wants to be processed. So you have the joystick, you have for those that play game and other things. Then we have the mic, we have the cameras, we have the touch tablets, the keyboard, and then the infrared temperature check. All these are used to send information into the computer. So those are examples of the input device. We have other input device that is not included in the picture, like the touch screen, the touchpad, the graphics tablets, the video capture hardware. Okay, I think it's there. The barcode reader, the gamepad, the scanner, electronic whiteboard, the webcam they have in your system, the pen input, which other one, and the trackball. A lot of them. So any device that's used to send information into the computer is actually an input device. Okay, so the most common used keyboard is the QWERTY keyboard. Okay, if you look at your keyboard, okay, you see it at the third row of the arrangement in your keyboard. You see it written there, QWERTY, from QWERTY. Okay, so that's the most common, and generally it has about 104 keys. So when you count what you have in your keyboard, is about 104. That's the most common. That does not mean that it's only the QWERTY keyboard that exists, but this is the most common. In fact, most computer systems have this kind of arrangement. Okay. Then the central processing unit. Just like we said, the central processing unit, the CPU, is the brain of the computer. Just like the brain of a human being, everything is processed from your brain. Okay, that's exactly what happens in a computer system. So the computer system has a brain, and the brain is the CPU. So all the functionalities, all the functions and processes that takes place within a computer is the CPU that is responsible. Okay, so just like I said, it's the brain of the computer. Basically, all the functionalities of the computer is being done from the CPU. And the CPU can be comprised of three main parts. Okay, three main parts. The CPU has, excuse me, three main parts. You have the ALU, referred to as the arithmetic logic unit. We have the control unit, and of course, we have the registers. Okay, I'll explain them one after the other. The arithmetic logic unit, the control unit, and the registers. So if you have your pen and your paper, you can actually, write them down as I'm explaining it. So the arithmetic logic unit. Now, basically, the ALU is responsible for all calculations. Anything calculation that you want to do, that you want the computer to do, the part of the CPU that is responsible for that is the arithmetic logic unit. So anything arithmetic, that part of the CPU is responsible, whether it's addition, subtraction, multiplication, or division. The arithmetic logic unit takes care of that. Okay. Then other logical operations like the computer numbers, letters, or special characters are also being taken care of by the arithmetic logic unit. So I'm going to repeat myself. I said the arithmetic logic unit is the part of the CPU that is responsible for calculations. Calculations like addition, subtraction, multiplication, division. And of course, if you want to compare numbers, letters, or other special characters. The arithmetic logic unit takes care of that. So that's the function of the ALU, the arithmetic logic unit. Then we have the second part of the CPU, which is the control unit. Now, what the control unit does is that it controls and coordinates computer components. All the various computer components is being controlled and coordinated by the control unit, just as the name implies, control unit. So the function is basically to control every component of control and coordinate all the components of computer. So what the control unit does, there are other functions. I just want to break them down. Other things that the control unit does is that it reads the code, okay, for the next instructions to be executed. So the computer knows what to do next after it's done with a particular function, a particular process. It knows what to do next, and it's a control unit that helps it, okay, to understand what needs to be done or what needs to be executed. Okay. It also helps to recover data, okay, required from the memory of the computer. Okay, the control unit also does that, and then also provides the necessary data that the ALU, okay, needs, okay, and also the register. So that's basic function of the control unit. So in summary, the control unit controls and coordinates the different components of a computer. Okay, then the third part of the CPU is the registers. The function of the register basically is to store the data that is to be executed next. Okay, probably if there's something you're doing on the system and you want to continue on a later date, or maybe your system just went off, or maybe in the case of a desktop computer, light just goes off and you've not completely finished what you're doing. The computer has not completely processed the data. The function of the register is to actually store that data, okay, that as soon as the light comes back, or you prompt the computer to continue, okay, that's what the register does. It can also be paused. There are sometimes you're doing something in the system and you just pause it. It stores temporarily in the register until you come back again and press the play. Then it continues from where it stops. Okay, so it's a very, very fast storage area of the computer. Okay, so it helps to store data for future execution. So that's the function of the register. So let me repeat what I just said. I said the CPU is the brain of the computer, which has three main parts. The arithmetic logic unit is responsible for every calculation that takes place in the computer. The control unit controls and coordinates every other component of the computer. And of course, the register stores data for future execution. Okay, so those are the three parts of the CPU. And then we have the primary memory. There are two memories that the computer has. We have the primary memory, and we also have the secondary memory. So I'm going to be explaining them one after the other. Now, for the primary memory, there are basically two. We have the RAM and the ROM. RAM means random access memory. Random access memory. So the primary memory has two memories: the random access memory and the read-only memory, the RAM and the ROM. Okay. Now, what the RAM does is that it is responsible for storing data on a temporary basis. As for the RAM, okay, it stores data on a temporary basis, so that maybe on a later date it can promptly be accessed by the processor as when the information is needed. So the function of the RAM is to store information temporarily until the processor is ready to process the information whenever it's needed. Now, one thing about the RAM is that it is very, very volatile in nature. It is very, very volatile in nature. So this means that data can be erased. once supply to the storage device is turned off. So that's why we said it's a temporary storage unit. Okay, so the volatility of the RAM is such that once there's a cut, you're going to lose that information that you have. So RAM stores data randomly, and the processor accesses this data randomly from the RAM storage. Okay, so it is considered random access because you can access any memory cell directly if you know the row and the column that intersects at the cell. I wish I had a marker or something. I'd have been able to describe what I'm trying to say. But in essence, what I'm trying to say about the RAM is that it stores data temporarily, and any hitch that this thing can be lost. Okay, so it stores it until the computer processor is ready to actually pick up the information and then process that information, that data, into a readable information. So that's the random access memory. And then for the ROM, the read-only memory, that is a permanent form of storage. So the RAM is temporary, the ROM is permanent. Okay, so it's a permanent form of storage. It can stay active regardless of whether power supply is being turned off or on. You see the difference between the RAM and the ROM. First, I said the RAM is a temporary storage memory, but ROM is a permanent storage memory. The second difference between the RAM and the ROM is that the RAM is very volatile, meaning you can lose your information once there's the power cut. But for ROM, whether there's power cut to or there's no power cut to, the information is still there. You cannot lose that information. Okay, so ROM devices do not allow data stored in them to be modified. That's about ROM. So that's the two primary memories that we have in a computer system, the RAM and the ROM. So the secondary memory, for the secondary memory, it stores data and programs permanently. Okay, it is retained even after the power is turned off, just like the ROM. Okay, it's also a permanent storage memory. It can also retain informations, whether there is power cut or not. So the secondary memory also works like the read-only memory. So the secondary memory can be divided into two. We have the hard drive and we have the optical disk. Those are the two types of secondary memory that we have, the hard drive and the optical disk. Now let me explain them one after the other for further understanding. Now the hard disk is part of a unit often called the disk drive. We all have flash. We all have this other one. All those devices that you use in collecting information from your system. The flash, the USB reader, all those microchips. All those ones fall under the category of a hard drive. Okay, so this hard drive can store informations. It can provide relatively quick access to large amounts of data. Okay, so that's the hard drive. It is used to store information, and it can also provide these informations. Now the information that is stored in the hard drive is large, depending on the size of your hard drive. Okay, so it can store large information, and anytime you need information, you can actually come and pick them up from there. Once you install it into your computer system, it grants you access to the information stored on the hard drive. Then the optical disk uses laser lights as part of the process of reading or writing data. Okay, is actually in form of like your DVD drive, your CDs. Okay, your CDs, your DVD drive comes in this. They are referred to as the optical disk. Okay, so you can also use them to store information, and you can also access them. Okay, so you just to slot it in, and then you also get your information just like the hard drive. But for the optical disk, They basically use laser lights, okay, to process this information. So those are the two types of secondary memory that we have. Okay, and there's also the flash disk, okay, which um, is also part of the hard drive. Now, let's compare the main memory, which is the RAM, and the secondary memory, which is the hard drive. Is there a comparison between them, the RAM and the hard drive? Yes. Like number one, the RAM, smaller amounts of information or data can be stored. I think it's usually between 500 MB to about 6 gig. Yes, that's for the RAM. But for the hard drive, it stores much larger amounts, okay, ranging from 8 gig to about 1,000 gig. So depending on the size. So that's for the hard drive. It can store large amount of information compared to the memory, to the RAM. So the RAM can, I think it's more than 6 gig. You check your phone, your laptops, you see that the highest we have is about 6 gig of RAM memory. But for the hard drive, it can take up to 1,000 gig. These new phones that we're having now, okay, when you check it, I think I've seen one of the 128 gig. And the more new phones and laptops are being invented, they increase the size of the hard drives and the rest of them. So it's quite much. It's quite much. Another difference, okay, comparison between them is that for the RAM, just like I told you earlier on, is a temporary storage for files and program. Okay, that of the hard drive is a permanent storage for files and program. Now, like I told you, anything once there's a disruption in the RAM, you lose the information. Even a spill, maybe you're working on your system and you have a coffee spill, you have a cup of coffee and it spills on your system. That's it, the information is wiped out. As small as a spill from a cup of coffee or coke or anything, you lose the information. But out of the hard drive, no. If the information will still be there despite the spill. Okay. The RAM consists of chips, that's microprocessors, while the hard disk consists of hard disk, like the platers. Okay, so these are some of the comparisons, the differences between the RAM and also the hard drive. Let's move ahead to output device. So I'm done with the input device. Now the output device is any piece of computer hardware equipment used to communicate the result of data processing carried out by an information processing system. What this means is that just like I told you, input device is used to send data into the system, into the computer for processing. Now, after the information has been processed in the computer, there's a device that needs to send the processed data in form of information now back to the user. So those devices that are used to now communicate the processed information is actually the output device. Okay, and examples of output device, we have them here. The webcam is also an output device. The speakers, the monitor, the microphone, the printer, the headphone. Okay, these are examples of um, output device. We also have the projector. Projector is also an example of an output device. Plotters is also an example of output device. The LCD projection panels, I don't know how many of you have seen that, is also an output device. And then the computer output microfilm, okay, which like they use them in medicine for scanning and the rest of them, x-ray and the rest of them. So those are examples of output devices. Then I think for the monitor now, there are basically three types of monitors that are being used, okay, to transmit this information, processed data from the system. We have the cathode ray tube, which is the CRT. It's not common anymore. The most commonest monitors that we have now is the LCD and the LED. The LCD liquid crystal displays, while the LED is light emitting diode. Even the LCD now is almost going into extinction. The more emphasis on the LED, the LED, because it has a brighter color. It transmits this data, this processed data, it's more understandable, it's clearer, it's the picture quality and the rest of them is always finer. And then for the printer, we have the three types: the laser printer, the inkjet printer, and the dot matrix printer. These three is still in existence up till now. So that is that for the output device. So quickly we'll proceed to the software. The software is a generic term for organized collections of computer data and instructions, often broken into two major categories. So we have the system software and we have the application software. So a collection of computer data and instructions that is used to understand a data or to process a data is actually a software. So for you to understand a particular information or data, or for a particular information or data to be processed or to be understood, to be interpreted, you actually need a software to run it. Like we said, there are two types of software. We have the system software and we have the application software. Now, the system software is responsible for controlling, integrating, and managing the individual hardware components of a computer system. So for every hardware that you have, be it your phone, your laptop, and the rest of them, there's a system software that is actually in it that helps to control, okay, and then manage all the various components of the computer system. So without the system software installed in your device, many functions cannot take place. Many programs cannot run in your system, in your computer device. So you need a system software installed. Usually it's a default software. It comes with every computer device. It's there. So that's that for the system software. Then the application software is basically to accomplish a specific task. So this one you have to, it doesn't come, most of the application software doesn't come as a default software when you get your computer system. So you have to install. You have to maybe go to the Play Store, or it can also be copied through a flash drive. So you have to get it. But the application software, it doesn't work generally like the system software. The application software actually works for a particular purpose. So if it's for game, there's an application software for game. If it's for Microsoft, maybe for for typing and there's an application software for. So what I'm trying to say is that the application software actually functions for a particular task. So depending on what you want to do, you have to get that, okay, for that to be for that particular program or task you want the computer to do for you to be possible. All right, so that is application software. Then I've also seen some that included in the third type of software. Outside the system software and the application software, we also have what referred to as the utility software. Utility software. I don't know if we've come across that. Okay, so this is a chart for the system software and the application software. I don't know if it's clear enough, but from my explanation, you'll be able to understand the two. Then the utility software takes care of the antivirus, the text editing, and the file management. So outside the system software and the application software, we also have the utility software. Okay, so those are the computer softwares that we have. All right. So if, for example, now let me go back to these types of software. If I ask you guys now to compare between the software and the application software from what I've said, I'm sure you guys will be able to do that. Okay, can we do that? I'm very, very sure about that. Okay, so for examples of, let me give you examples of system software. We have like the Microsoft Windows is a system software. The Linux or Linux, according to some persons, is also a system, an example. The Unix, the Mac OS X, and the DOS, these are examples of the system software. Okay, then for the application software, we have the Opera, your web browser is an example of application software. The Microsoft Word is an example of application software. The Excel, the database software, the PowerPoint, the Adobe Photoshop, all these are examples of application software. Okay, now how do they interact? How do you interact with the system software and the application software? Now, for the system software, the user do not interact with the system software as it works in the background. So the user cannot be able to interact with the system software. It basically works in the background. But for the application software, the user is able always, the user always interacts with the application software while doing different activities. So okay, that's that for the system software. So that's like comparing the system software and the application software. And then another thing, dependency. For the system software, it can run independently of the application software. It can run on its own. It doesn't need anything to work. But for the application software, it cannot run without the presence of the system software. So those are the two major comparison between the system software. System software doesn't need anything to run. It runs independently. But the application software still depends on the system software for it to be able to work. Okay, so that's that. So let's go. So I'll be able to finish what I have today. I have about 4 minutes left. And the unit of measurements, you have the bits, the neighbor, the byte, kilobyte, megabyte, like that till yottabyte. They all have their readings, their storage and capacity, okay, from the bytes to the highest and the rest of them, okay. Then the speed measurement, the speed of the central processing unit is measured by hertz, which represents a CPU cycle. So the speed of CPU is known as the computer speed. And of course, the processing speed is measured in hertz too. And then it spans from the megahertz to gigahertz, like that. So 1 gigahertz processor executes 1 billion instructions per second, while 2 executes 2 billion instructions per second. All right, computer classification. Computers can be generally classified by size and power, like that. So we have a personal computer, we have the workstation, we have the mini computer, we have the mainframe computer, and also we also have the super computer. Okay, so those are the classifications of computer according to the size and the power. But the personal computer is small, single user computer, and it has a microprocessor. For the workstation is also a single user computer. Okay, the mini computer is multi-user, more than one person can use it. The mainframe is a powerful multi-user computer, while the supercomputer is extremely fast computer. But that's where we are right now. Okay, then the laptops and smartphone computers, we have the laptop, we have the netbook, the netbook, we have the mobile device, we have the tablet computers, then like that. So basically, computer is for data, for information, and then to transmit knowledge to us. Okay. I wish I had time. I would have been able to explain these three things, but just understand that computer basically receives data, it processes it into an information for our understanding. That's what that is. And then finally, characteristics of computer are speed. Computer has an enormous speed. Okay, the processing rate of a computer is very fast. Within it can process millions of instructions per second. That's how fast or how the speed of a computer. Accuracy is what you give the computer that the computer will give you, and there's a very high degree of accuracy as far as that is concerned. Diligence, it can work for a longer period of time. It doesn't break down as long as everything is okay. Storage capability, like we said, it has the ability to store a lot. Versatility, can do 3, 4, 5 different things at the same time in a computer system. All right, so I think this will be ending the class today, but I'm going to give a quick assignment because I just have 1 minute left. And the assignment is, are computers limited in any way? We've just looked at the characteristics of a computer: speed, accuracy, diligence, storage capability, and versatility. Are computers limited in any way? I want us to discuss that, ponder on that, and then you send the information to my mail, which I'll be dropping later. Then list and explain the applications of computer in various fields of endeavor. So I'm expecting in field of medicine, in field of agriculture, in managing the environment, in education, just different fields of endeavor. What are the applications or use of computer? How has computer helped in these various fields of endeavor? So I want us to also discuss that. And then how has computer evolved over time? How has it evolved over time? Before now, we used to have for you to have a computer system to work, you need a big distance as big as this room. It's always heavy. But now, look at what we have. Very tiny. So I want you to look at it from the first generation to the fifth generation that we are currently. How has it evolved? So be able to discuss that for that. All right, so that's the end of the class. I hope we all enjoyed ourselves. I don't know if I have time to take one or two questions from what we've been able to discuss this morning. Any question from anybody? Does anybody have question? All right, there's no question from anyone. I think be calling it a day. Thank you for your time, and I'll see you guys next week.